Okay, future elementary educators of the world, it is time for us to march toward the final exam. And we do that by taking a look at decimal numbers, which will bring a lot of what we have been talking about all semester long right back to the forefront. It's a great way to head into final exam. I asked you to do this. I asked you to write down a bunch of unit fractions and their decimal equivalents. And some of them terminated and some of them didn't. So I'm sure that you wrote things like 1/3 repeats and 1/7 repeats. Right, I'm sure you wrote things like that, and I'm sure that you wrote things like this doesn't, and you have this big long list of terminating decimals, repeating decimals, and you're trying to figure out what makes the difference. What makes the difference? This one doesn't repeat. This one doesn't repeat. I don't know what this. Yes, I do. This one doesn't repeat, but this one does. This one does. So what makes the difference? Why do these numbers give us decimals that stop while 3, 7, 11, and 12 don't? What makes the difference? And the difference, so then I tried to set that up. What makes the difference? Well, let's look at how factorings work. This is 2 times 2. This is 2 times 5. This is 2 squared times 5. This is 4 times 100. That's 2 to the 4th 5 squared. Right? This is 5 to the 1. Whereas that's 3, that's 7, that's 11, that's 2 squared times 3, and we could go on. But you can probably already guess what the deal is here. So what makes the difference? If the denominator has factors of only 2 and 5, then the decimal will terminate. Otherwise, the decimal will repeat. And that's a hard and fast rule. That's what makes the difference between the fractions in the left column and the fractions in the right column. The fractions in the right column have a denominator with some factor that isn't 2 or 5, whereas the denominators in this column have factors of only 2 and or 5. Just 2's, just 5's, 2's or 5's. Anything else forces a repeating. So then I asked us to think about decimals that repeat, like 1/7. So you divide 1 by 7, and you're like, how the heck do I do that? Well, I know how to divide. I mean, this is something I learned when I was young, right? So how does this go? 7 goes in at 10, right? And then you do this subtraction, and you get a remainder of 3. Then you're like, well, let's bring down that 0 and let's try again, right? You did this when you were doing the worksheet. You got a remainder of 2. Then you brought down the 0 and you're like, well, I can lather, rinse, repeat this, right? You got a remainder of 6. You're like, well, let's just keep going because the digital paper just keeps going, and you got a remainder of 4. And you're like, well, that's a new remainder. I've never had that one before, right? And then you're like, yeah, I got a remainder of 5. And you're like, okay. And then, whoa, that was not okay. And then you're like, okay, well, let's try that. And then the craziest thing happened. You got a 1. So you had a 1, you had a 3, you had a 2, you had a 6, you had a 4, you had a 5, and now you're back to the 1, which means that the next thing that you write up here is going to be like something you've done before. There's something there that you have done before. And so you got this thing, as soon as you see a remainder that you've seen before, as soon as you see a remainder that you've seen before, we now know that's the block that's going to repeat. Because once you see this whole process has to happen over and over again. You can explain that to a young person. A young person's going to figure out that that has to be. And then you're gonna try it again. You're gonna say, oh, really? You're gonna say, I can do this. Let's try this with 13. I mean, how far could this possibly go? No one knows, right? I mean, nobody's actually done this, right? 13 goes into there 7 times. And you're like, okay, I haven't seen a 9 before, so we'll try this again. And that goes in 6 times. And then we're subtracting, and you're like, I haven't seen a 12 before, so let's try that. That's a 9, right? Because that's 117. Now I haven't seen a 3 before, so we'll bring that down, and that's a 2, right? Right? We can do this. We can do this. That's a 4. We haven't seen a 4, but whoa, whoa. We haven't seen a 4 before, right? And then there's the 3, and then looky you. That is something we've seen before. And so now we know that this is the block that repeats. It's 076923, 076923, on and on and on, over and over and over again. Because every 6 remainders, that one's going to pop up again. And so then we asked, what are the possible remainders? So just thinking this through, because you're college students, so you can think this through. When you divide by 7, what are the possible remainders? You can get a remainder of 6, or a remainder of 5, or a remainder of 4, or a remainder of 3, or a remainder of 2, or 1, or 0. These are the possible remainders when you divide by 7. So you're like, okay, we can use different remainders. We can have these remainders be different for a while, but no more than 7 times, right? Because then one of these has to pop up again. And once one of these pops up again, the thing has to repeat. Or it runs out. And if it runs out, then it repeats forever with zeros. So same sort of thing is happening down here. What are your possible remainders? All your numbers from 0 to 12, all your whole numbers from 0 to 12 are possible remainders. So we can go 12 different remainders, no problem, but the 13th has to be something we've seen before or something that stops the whole process. So for us to remember, every rational number becoming a decimal has to repeat. It is not possible to go on and on forever and ever without repeating because there are only so many remainders to go around. That's a key thing to understand. Not something that your students will have to verbalize, but something that your slick students may ask about, and you want to be ready to talk to them about that. Okay, those are my answers. Hope they are helpful to you.